Hi everybody, Matt Morgan here. In this lesson we're going to work some problems from Wiley Chapter 3, working with heat transfer, and specific heat. We'll go over some strategies for solving heat problems. Specifically, we'll do Wiley problem 03-75, and then one of the reading exercises, 3-5D. So at this point in the course, we start to do a lot more numeric problems.
No! No! No!
If you're not a math person, however, don't despair. Solving problems is a learned skill. If it doesn't come naturally, you will improve the more you do it. It may take some time, perhaps some more coffee, but you can get this. So both the reading and the homework, they have some great problems, very applicable. The best piece of advice I can give for working these problems, and if you've talked to me, you've heard me say this, keep track of your units. We've done dimensional analysis problems before, and these problems can be worked using a very similar strategy. You want to make sure you look at your target units, your given information, and how to get from your given units to your target. Let's work some examples. First, we'll do Wiley problem 3-75. This is from the assignment 3QB. There's the wording. They talk about the specific heat. They don't mention the metal. They say it's a low specific heat. 5.26 grams evolves 7.61 calories when it cools from 54.5 to 12.8 degrees C. This is a little bit different because usually we're given a specific heat and use it to calculate a temperature change or how much heat is evolved or absorbed. In this case, we are going to calculate specific heat. That's all right. If we follow our advice and pay attention to the units, we can make this problem work. We remember from the previous reading and the previous video that units of specific heat are either joules per gram degree C or calories per gram degree C. In this specific problem, we're given a calorie value, so we're going to use calorie per gram degree C. That's what we will calculate. We arrange our given information. We'll put calories on top, grams and temperature on the bottom, do our math, and we will have our specific heat. One of the keys to this, don't think about this too much. Just apply your given information, make the units work. Here's the problem information again. So what we do to find our specific heat, we're going to put calories on the top, 7.61. We will put our grams and our temperature change on the bottom. That will give us the correct units. Do the math, 7.61 divided by 5.26. Take that number divided by 54.5 minus 12.8. Go ahead and work it yourself. Maybe press pause. Work it yourself. See if your answer matches mine. Maybe I'm wrong. I get 0.0347 calories per gram degree C. Our given information is 3 sig figs. Final answer, 3 sig figs. All we do is make the units work. That's a pretty small value, but the problem did mention that the value was small. Passes the common sense check. Let's move on. The next example's out of the reading. It involves heat lost and heat gain. Exercise 3-5D, it's at the end of reading section 3-5. 20-gram piece of hot iron. Its initial temperature 225 degrees, placed in 51 grams of water. They just say no heat escapes, so we can work it. The water and the iron end up at 45 degrees C. They want to know how much did the temperature of the water increase. So once again, we're going to use our formulas, we're going to pay attention to our units, and not think about this too much. There is a bit of bookkeeping, but we'll organize our information, we'll keep track of units, we will get this. So heat flows from the iron, because it's hot, into the water. The water is definitely colder than 225. So it will flow from the iron into the water until the temperatures of both are equal. So the equilibration temperature is 45 degrees. An important point is the same amount of heat flows out of the iron and into the water. Earlier in the reading, we see a formula that negative heat lost equals heat gained. That matches our common sense. We have to put the negative sign because heat flows out of the iron and heat flows into the water. If you don't put that negative sign in, your answer's not going to make any sense. And we'll show that when we plug in numbers. So looking at our units, we see that the heat is the mass times specific heat times delta T. We've also seen that formula in the reading. So we can do this problem either in a couple of steps or put it into a single equation. And I'm going to work the problem using both methods. There's our information again. So first we're going to figure out how much heat the iron loses. We're not given its specific heat, but we'll look it up in table 3-2. If this problem were given on an assessment, you would be given the specific heat. Don't worry about memorizing those values. So we'll look up iron specific heat. There it is right there. A question you might be thinking, which specific heat should we use? It doesn't matter. As long as we use specific heats with the same units for iron and water. We can either use calories or we can use the joules, but they have to be the same for both. I'm going to pick calories because water is one of our substances and the specific heat of water is 1 calorie per gram degree C. So that's going to make the calculations easier. I'm going to use calories. It's arbitrary though. You could use the joule values and still get the correct answer. So given information. Okay, so the amount of heat iron loses, 20 grams, 0.106 calories per gram degree C. We got that from the table. And there's our temperature change. So the amount of heat iron loses, go ahead and punch those numbers out, press pause, make sure your answer matches mine. Okay, we know heat is mass times specific heat times change of temperature. Notice that grams cancel, degrees C cancel, our final unit is calories. Okay, now numeric answer I get minus 381.6 calories. Now the final answer for the problem is going to have two significant figures. It changes from 3 to 2 due to the subtraction, but I'm going to carry extra digits until the end of the problem. So why do we get a negative number? Because heat flowed out of the iron. That makes sense. This same amount of heat is absorbed by the water. So now we're going to solve for delta T in the second part of the problem using this amount of heat, the mass of water and water's specific heat. We put a negative sign because heat lost equals negative heat gained. 51.0 grams of water, 1 calorie per gram degree C, and we solve for delta T. That's our unknown. Our units will work out. Heat lost, negative heat gained. You work out the problem. Hopefully you get 7.5 degrees C. If you forget to put the negative sign in, you're going to get negative 7.5 degrees C. And that doesn't make any sense at all, because putting a hot piece of iron is going to make the water temperature go up. It's not going to make it go down. Now you can also solve this problem by using a single equation. Now I want to give you a warning. If the first method works for you, you want to do 2 steps, that's great. If seeing it a different way is going to confuse you, it's alright to stop watching now. But if you want to see this problem solved in a different method, keep watching. So I'm doing this last part just to show you that there are different ways to solve this problem. Also, for this method, I'm going to use the joules per gram degree C just to show you you'll get the same answer as long as both are calories or both are joules. There's our information. We know negative heat lost equals heat gained. We plug this in, heat lost by the iron. I'm going to put the negative sign, 20 grams. There's our specific heat for iron in joules per gram degree C. There's our delta T equals heat gained by the water, the mass of the water, specific heat of the water. Our only unknown is delta T. If I do the math, solve for delta T, I get, once again, 7.5 degrees C. So if these problems seem difficult or confusing, practice, spend time working on them. If you put the time in, you will improve. You are taking online courses, but you are not alone. There are lots of people out to help you, most importantly, your course mentors. Here's our contact information one more time in case you need it. The main job of your course mentors is to enable your success in these courses. You can email us at the group inbox at chemistry@wgu.edu, or you will find contact information for your individual course mentor in your course of study.